Hi, kiddos. I know that you can't see me, and I'm sorry. I just need to update something on my computer, and so I can't put my beautiful face there, but I really wanted to make this quick video because I've been seeing a lot of misconceptions around this, and I want to make sure that we are all clear on FoRcEs, okay? So if you hear weird noises in the background, it is my children. They're supposed to be napping. They probably are not, but I'm hiding in the basement, so such is how it is. First of all, I miss you. I miss you all, and I can't wait to see you again. But we are preparing for this AP exam, and we are preparing our butts off. So we need to talk about FoRcEs. So a few things that are important. When we're talking about different types of solids, okay, or different types of, you see I'm using Bell Blue, my favorite color, different types of substances, I guess we'll talk about, or compounds. The important thing to remember is that there are different forces holding different ones together, okay? So a network solid, which is not, I have not seen anything about on the AP exam in a long time, so I'm not going to spend a lot of time on it, but a network solid is something like diamonds, or graphite, or graphene, okay, sand, glass, silicon dioxide. This is held together by covalent bonds. So when you melt it, you are breaking covalent bonds, okay? So that's why they have such high melting points, because you're breaking actual covalent bonds. Those are the only real examples that you need to know: diamond, graphite, probably silicon dioxide and silicon carbide. But those are the four, okay? Another one, this is where we're making our most mistakes, are ionic substances, okay? Ionic substances have a force between the ionic particles, but you got to remember that there's no molecule in ionic substance, okay? So salt doesn't look like this with an Na and a Cl. Make sure you don't forget about your charges. Salt looks like this. There's an Na and a Cl, and an Na and a Cl, and an Na and a Cl, okay? So it's like a lattice. And that's why when we talk about ionic substances, we talk about lattice energy. Lattice energy is the force that's holding those things together. So when you melt it or you break an ionic bond, so this is for melting or bond breaking, or forming, I guess, if you will, you are breaking those forces right there. They're electrostatic forces, and it's lattice energy. So that's where Coulomb's law comes in. And I know that Coulomb's law can be confusing, but I really need you to know it cold. So Coulomb's law says that the force between those two particles is equal to the charges on them over the radius, okay? And I know that radius is squared, and I know that that video was like, well, radius matters more. It does because it's squared, but here's the deal. You're not going to have a radius doubling, per se. Ionic radii are not going to change that much. Ionic radii are going to go from 108 picometers to 130 picometers, okay? Whereas your charges are going to be +1, +2, or +3. So when you're comparing +1 to +3, that's triple, okay? That's triple the charge. So be aware of this, okay? As charge goes up, your force, and therefore your lattice energy goes up. As radius goes up, your force or your lattice energy goes down, okay? Ionic substances have no London dispersion forces to talk about. They do not have London dispersion forces, they do not have dipole-dipole forces, and they do not have hydrogen bonding, okay? So let's make sure that we don't talk about London dispersion forces when we're talking about ionic, and that's where most of you are going wrong. How do you know you have an ionic substance? The biggest thing to know is you've got a metal and a nonmetal. Okay, if you've got a metal and a nonmetal, you've got ionic, you're talking lattice energy, you are not talking London dispersion forces. Now, if you are talking about something that's molecular, that's where we live over here, okay? I got to get back to my color. Molecular. How do you know something's molecular? It's all nonmetals and not nonmetals. Can't talk and write, guys. And it's all nonmetals and not one of those network solids we talked about, okay? So like water, H2O. Doot, 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 doot. Remember, on this AP exam, you're not going to have to draw anything. So water is a molecular solid. That right there, this guy, is a polar covalent bond. If I am reacting water, I am breaking that polar covalent bond. However, a hydrogen bond in water is right there. It's between one water molecule and another water molecule. So your molecular substances that are made up of all nonmetals, these are the ones that all have London dispersion forces, okay? The bigger the electron cloud, the more polarizable. You guys are killing those explanations. You are telling me that it has a greater electron cloud, therefore it's more polarizable. You are using the right words. You are doing great, 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 great at that, okay? They could also have dipole-dipole forces. Dipole-dipole are for polar molecules only. And they could have hydrogen bonding, which we know is FON. Okay, so when you have hydrogen bonded to an FO or an N, it can hydrogen bond to another molecule. Make sure you're very clear that these are intermolecular forces and not intra, okay? The AP exam is very aware that some people think that that's a hydrogen bond. No, that allows the molecule to hydrogen bond, okay? So here's what I need you to do. Ooh, look at that. When you are writing an answer, because we've seen this a lot of times already, okay? When you are writing an answer that's comparing a boiling point, a freezing point, a melting point, something along those, a vapor pressure even, of one substance to another substance. So if I'm looking at Br2 to HCl, okay? I need you to answer it in 3 sentences because this is how you're going to put yourself in the position to get the most credit. Sentence 1, you need to list the forces. I can't write, sorry. In, that's A and that's B. You need to list all the forces in A. And then you need to list all the forces in B. Now, the examples we've been doing have been having you compare ionic things to molecular things. So this example I gave you here is not, but if I'm asking you to compare something that's ionic, your forces are going to be lattice energy, okay? They're going to be ionic electrostatic forces. But if it's molecular to molecular, that's when you're talking LDFs and intermolecular. Then for step 3, you're going to do the compare and explain. Okay? All the forces in A, list them out. All the forces in B, list them out. And then compare them and explain. Usually you'll have some data to support you there. You'll say, oh, the melting point of Br2 is greater than the melting point of HCl. Therefore, the forces in A are greater than the forces in B. This is due to the larger electron cloud and the greater London dispersion forces. So you need to compare, use your data, and explain. Anything with intermolecular forces, you need those 3 parts. Hopefully this was clear. If not, please, please, please send me a text message and or an email, and I will make another video and make it clearer. Okay? Thanks. Bye, guys. Miss you.